My name's Daryl.
I'm Josh.
I'm Jorden.
And we're one of NORCAT's residents by the name of CMD Prototyping. It's actually kind of interesting for us because we were on the other side of this last year, and now they're telling us we have to teach it, so just kind of adapting to that. So tonight we're going to be talking about contract manufacturing, which is one of the kind of more terrifying end steps in any product-based company. It's kind of a bit of a necessary evil, really. So hopefully we can try and give you some information that'll help in terms of, you guys when you get to that step.
So basically what contract manufacturing is going out of house to find people that have a skill set in a particular area that might not be your firm's strongest point. For example, if you have a great idea for solving a problem, but you're not really mechanically inclined, then getting somebody else to build a prototype or a final product for you. It should not compromise your core competencies. So if it's something that your company does state that they say to the public, so let's say you are doing some molding, you're not going to hire a company to do the molding for you because it kind of takes away from your own value proposition. So a local example here is the Fortin Discovery Lab, which is what we're part of. Basically, if you need rapid development on something as well as small mold making, we do it here. A lot of companies that come in, again, have that idea or they have a prototype they made in their shed, but they don't know where to go forward from there. So a global example is Apple. So while they have a lot of the software for all of their devices, they don't necessarily make all of them specifically, the iPad and the iPhone. Those are made through Foxconn, which is a company that specializes in manufacturing these electronics. It does kind of bring into question when you say that my Apple phone is a lot better in quality than your BlackBerry when they all came off the same assembly line. Same thing with an Xbox versus a PS4. They're all made in the same factory. So ultimately it does kind of affect competition to say that yours is made so much better than somebody else's. But at the end of the day, both are made better than the company themselves could make in-house.
All right, so one of the biggest questions when you're dealing with contract manufacturing, since it's such a big step, is are you ready? The first thing you want to consider when you're dealing with that question is the actual design of the product. So the first thing you really want to think about is kind of the surface qualities. Have you thought about what materials you're using? If your part is actually an assembly, how are you putting it all together? Are you using fasteners? Are you using bolts, glue? You need to think about all these things to start with. And then you need to go into a little bit more detail. So if the product is actually engineered, did you get the correct stamps, all the correct certifications? Is it going to withstand everything that it needs to when you put it out in retail or out in industry? And so you really need to think about the purpose and if the design itself is actually appropriate to be manufactured. So some designs are better for manufacturing, some are better for prototyping. I'll go into a little bit more detail about that later on, but you really do need to think about the surface qualities of the part first. After that, you need to think about the cost. So there is a much larger cost associated with contract manufacturing, especially the upfront cost. So when you're dealing with smaller volume and prototyping, the per part cost is much higher. So a 3D print might cost you $50 to $100 a part, whereas contract manufacturing parts will typically cost you more in like the cents, 1 cent or 2 cents to $1 for plastic parts or something along those lines. But the initial dies and the tooling can cost you $100,000. So that investment really needs to be thought out, and you need to go back to some pretty basic economics and look at your supply and demand. So is the profit margin on the part that you're going to make and the volume that you're going to sell it at make up for the large initial cost of the process? There's also, as I mentioned, certifications. Certifications can cost quite a lot of money, like FCC and CSA testing for electronics, for example, can cost as much as $15,000. And that's something that some people don't quite realize when they go into it, but that can be a significant cost, and it's something you have to think about when you're doing this. And finally, there's retail and storage space. So when you're manufacturing a whole bunch of something, you're going to need to have stock, and that can cost quite a lot of money as well. So all these things are factors that will play into the equation you have to think about before you really go into contract manufacturing. And lastly, kind of the offset to cost is the sales. So do you have the proper marketing? Do you have all the clients and customers that you're waiting for? Do you have projected values? And how are you dealing with your suppliers and your retail partners? So do you have proper communication? Are they giving you feedback? Will they let you know how much you need and change the amount that the manufacturing is actually supplying you? So all these things are really the factors that you have to think about before you start the process of contract manufacturing.
So finally, you have your idea, your prototype is done, you're ready to get it manufactured on a large scale and start selling your product. Finally, towards the end goal of that company, you're actually able to turn this into something you can do for a living. Then there's the big question of domestic or foreign. So how many of you guys look at everyday products you buy and see made in China on there somewhere, or made in Taiwan or something like that? This is kind of that big question. To put it short, it's always cheaper to go foreign. Doesn't always mean it's the best choice. It's just in terms of straight up cost, that is why you always see made in China more often than made in Canada. So we're going to kind of go through those two, and I'm going to admit I'm slightly biased to Canada because I live here, but we'll give it a fair shot. So like I said, always the overall cost is with China. We quite simply cannot beat the cost of labor over there. So generally, if you are getting things mass manufactured, it will cost you less from overseas. That being said, though, there are often more support opportunities for getting your product made here in Canada. So for example, the Canadian government really likes seeing things built in Canada. It means the money is staying within our economy as opposed to spreading out to other countries. So you can generally try and find funding from things like FedNor, IRAP, Canadian government, anything like that, to help actually keep your product development here within Canada. People tend to encourage it. It's better for the economy. So, there's always new ways of trying to make sure that you as your company can pull that off as opposed to going overseas. Then to get into other aspects, there's always the problem of quality assurance. So the second you're getting your part mass manufactured by a contract manufacturing, you have to realize that this is taking essentially your baby, the company you've been working on or you and your team have been working on from the start to the finish, and now it's not in your hands to build it. You're going to get them all in a box, and you just kind of have to hope that it's exactly what you wanted. So overseas, you tend to have very, very little control or guarantee. More or less, this is just because it's harder to communicate, the relationship is a little bit harder, it's not exactly possible to, or well, it is possible, but not exactly likely for you to go and check out the facility and see examples of what they've done before. It's more or less taking it on just faith that they can do what they say they can. Also domestic, there's usually a higher standard of care and faster time to revision implementation. So what this means is if you do get your part and it's not quite the way you wanted, like maybe they're using a plastic that's cheaper than you wanted. Maybe they're using a rubber that you find is crumbling and it's not supposed to. That's generally a lot easier to fix domestically than it is overseas. So in a domestic company, you call them up, you go visit, you send an email, whatever, and you kind of address the exact material problems you have, and that can be adjusted. Overseas, it really depends on the availability of what they use. So most of those firms, like Jorden had mentioned, they manufacture huge amount of product lines from all sorts of different companies, and they simply have just warehouses of materials in stock. If what you want isn't what they have, you might be out of luck. Including in domestic, there's usually more involvement in the process. So what I mean by this is, for example, we've done some work for companies around here, and when we're making something for them, we quite often bring them into the shop where we work, show them the entire thing, and that way they've got a very good example of, this is exactly what these guys do, this is exactly what they can kick out, now I know, now I can, I can count on that. That is something I have seen from my own, with my own eyes. Whereas, again, overseas, that's a little bit harder to do. So the next big one is relationships and communication. Your contract manufacturer is going to be one of your biggest business partners as your company grows. They are literally making the product that you're going to be selling. So this isn't just a simple, walk into a store, give them a certain amount of money and take what you want. It is a relationship that will build and grow, ideally, with your own company. So face-to-face meetings and site visits always establish a better working relationship. Again, this is a lot easier domestically than overseas. It's easier to drive from Sudbury to Toronto to meet your manufacturer than it is to go from Sudbury to China, or Sudbury to Taiwan, or Sudbury to Thailand, etc. There's also, and I felt a little bit bad about putting this on here because it didn't sound the most politically correct, but you're less likely to have a language barrier with companies around here. So what I mean by that is, I get a lot of emails from companies in China often saying like, hey, do you have any parts we can build or manufacture for you? Here's our resources, here's what we have available. And it can oftentimes take a little while to go through everything that they sent me and translate it into what I understand. So here in Canada, that's a little bit easier, especially if they're near you. They'll know the same lingo. They'll know exactly what you're talking about. Again, not always guaranteed, but more often than not. So if your part or your product requires any difficult explanation or anything like that, you might have a better luck of domestic than you would overseas. Finally, there's more work involved in finding and establishing domestic manufacturing, which is actually a negative to domestic. So an example is, like I before mentioned, I get emails from companies in China constantly saying, hey, do you have any parts we can build? I've never received an email from a company in Canada saying, hey, do you have anything we can build for you? So I 2 emails a week from China offering to build me things, and if I ever wanted anything in Canada, I'm going to have to go hunting for them. So just that ease of actually finding the company is generally in favor of overseas. So depending how much you're willing to work, it can go one way or another, depending what you want. So, yep, okay.
So there's some key points with cost. They've covered it a little bit, but economies of scale is a major one. So going from making 10 products to 100 products to say 1 million of them, there's a huge cost reduction with the more you make. And this works for both sides. That's why you get the cost reduction. A company who is looking on to take 1 million run of your product is going to be more likely to work coercively with you. You're a bigger client to them, they can't afford to lose you. Whereas if you're going to a company that already makes millions in a run and you want them to make 1,000 for you, they're going to be a little bit resistant to that. Also, just from tooling costs, which I'll get into in a little bit, it's a lot easier to make a high run because the mold is your investment cost, your cost up front versus your cost per product. So that's basically what I was just talking about. So making a mold, an aluminum mold to make a run of 10,000 parts, it's going to cost you a lot up front, but your cost reduction per part is going to be substantial, which means if you make 10,000 but your mold is rated for 100,000, making the 100,000 is almost always a better option. Keeping in mind that you're now going to receive 100,000 of these and you have to put them somewhere, you have to sell them, you have to move them. So it's important also that when you're doing this, if you're going to get 100,000 of them developed to your door, that you're working with somebody who knows what they're doing. That you're not just picking anybody at random or shooting a dartboard at a map to try and find the place you want them manufactured. You don't want any small errors that happen in the development process of less experienced companies. The lack of hands-on control is a major one. So if you're building a prototype yourself and say you're building a phone case and then you realize that the button doesn't line up with where it goes on the phone, you can make another prototype. But if you haven't done that work preemptively, you're going to get back these 100,000 wrong cases. And it's on you because you didn't see the design flaw. It's not an issue they made. They made exactly what you sent them, but sometimes you don't notice these things until you have a bunch of them in front of you, or until the customer has tried using them and realized that they don't quite meet the need that they're supposed to. It's very hard to streamline a production outside of house. So if you know that it's so much easier to put this bolt in first rather than last, you don't have the control to say that to somebody. To say that you'll save a week on every run of your production if you do it this way, they're not going to take very kindly to that. Because you're not making it yourself, you lose that amount of control. Again, with your run size, they're going to make the 100,000 for the big client before they make the 1,000 for you. So it's something to keep in mind as well. If you're looking for a rushed part, maybe go with a smaller company rather than one that does massive orders for Apple or for BlackBerry. And on the note of rushed parts, it often will cost more because they are putting you ahead of other clients. Unforeseen issues, so I've gone into that a little bit with your design issues, but you may also have manufacturing issues. Perhaps you said that it needs to be made out of this certain plastic, but in fact, it'll only be strong enough if it's made out of a different one or of a metal. That's why it's very important to make sure that you've tested with your client before you get this run done. One key way of doing that is focus group testing. Maybe somebody will suggest an alternate use that you hadn't thought of, or an addition to the problem that you hadn't even considered. Understanding the needs of your client must be a priority. You must be designing for the end user, even if you're making it for 100,000 end users. You have to make sure that you're keeping in mind why you made this product in the first place.
So like Jorden was talking about a little bit, the design needs to be focused on the end user, but it also needs to be focused on how you're going to make it. So some designs are meant to be made in a certain way, but not in another, and you won't have control over how they do it a lot of the time. But there are some standards that you can adhere to. For example, right now we're working on a project where a client wanted something 3D printed. So we made the entire design based on a part that could be 3D printed and implemented that way. However, if you went to injection mold that, we'd probably get laughed at. So the injection molding just wouldn't be able to make this part. The walls are too thick, it's not consistent enough, et cetera, et cetera. But for 3D printing, it's pretty much perfect and it works exactly the way we want it to. So when you are designing your part, you may want to work with your manufacturer as opposed to just hand them something at the end. In that way, you're kind of going to reduce a lot of the wasted time because if you hand them something that they can't manufacture, they're going to tell you to redesign it. So some of the different ways that things are manufactured, the first that I'll go over is additive versus subtractive manufacturing. So additive, the stereotypical example is a 3D printer. So you take one layer of material and you add another layer on top of it, and then you keep doing that until you have your final product. Whereas with subtractive, for example, a CNC, you take a block of material and you actually take out the parts that you don't want. So any type of cutting, plasma or water jet would be examples of that too. So then small scale, you'd have 3D printing for plastics. Large scale, you'd have injection molding. And they work very differently, so you have to take that into account when you're designing it. For metals and aluminum, you're looking at CNCing versus casting. So CNCs are very precise, you'll get very, very small tolerances, whereas casting will often produce slightly more warped parts, but you can have a lot more of them. And both injection molding and casting have the same kind of drawback with the high cost for tooling and initial setup. Then finally, for electronics, you have prototyping boards. So a common example is an Arduino, and they cost about 30 bucks, whereas a printed circuit board will cost you about $1, but you'll need to order like 2,000 of them. The next thing you need to kind of keep in mind is the actual material of the product. So a really good example of this is Apple. People love their products because of how they look, how they feel. The design language is an important aspect. So you need to keep that in mind. If you want to sell a lot of something, you need to make it look good. You need to keep the aesthetics in mind. The thing is, material can have one of the highest impact on the overall cost of your product. So maybe you want the carbon fiber, you want the titanium, but will the fiberglass or the aluminum do instead? So you need to keep that in mind. What's important? Is the cost worth it, and will it attract customers, or will it just be an added drawback? The other side of that is the actual engineering side. So if you have minimum strengths or thermal tolerances that you need to keep in mind, that needs to be followed first. So you need to at least adhere, if not exceed, the specifications that you're given. And finally, the tolerances is kind of important. So when you're designing something, a lot of people don't realize this, but the part won't always come out in the exact size that you've designed it. So you need to allow for essentially wiggle room. And as you make tolerances smaller, it will increase the price of the part exponentially. So you want to make something that's as robust and that can be as flexible as possible in terms of size. So the last thing you kind of want to think about when it comes to design is the actual timing of it all. The first batch, when you make something with contract manufacturing, will take a lot longer to produce because the dies and the tools and the casts all need to be made. And that'll take a significant amount of time. So your first run will take a lot longer than your following runs. And also implementing changes at this point in time is very costly in both time and money. So you kind of want to minimize that as much as possible. And the last thing you want to look at is controlling your volume. So you want to kind of manage all of the manufacturing, the product assembly, the shipping and the storage all together. And you want to get feedback from your retailers, from your clients, from whoever you can, so that you can optimize that and grow your company and scale it in a way that's appropriate.
So intellectual property is something I won't go too much into because I know you've had a talk dedicated completely to it, but it is something to think about when you're doing contract manufacturing. Essentially, you're going to another company and you're saying, here, make this for me. How do you know they're not going to make a copy of it and sell it to everyone else themselves? So intellectual property is your best defense against that, having a patent on what you're making. And importantly, especially if you're going to be offshoring, is to have a patent that is outside of Canada as well. So there's actually a treaty that encompasses 142 countries, where if it's patented in one, it's patented in all of them. It's also important to keep in mind here trade secrets. So those are things that can't necessarily be patented, maybe a specific way that you do something, or a specific component of your design. So like an example here is 11 herbs and spices from KFC. It's not something that they can patent, they can't own it. And so if they went to another company to make their chicken for them, they have no control over them using that for all the rest of their recipes. So it's always important to keep that in mind. And it's something that is more of an issue, like I said, outside of Canada. If you see a company, in Toronto that's doing your manufacturing and then they open up their own store selling the same product as you, it's a lot easier to litigate, a lot easier to deal with here in Canada than it is to deal with in China, because you're dealing with a whole bunch of different laws and different ways to approach that. So again, the Patent Cooperation Treaty, that's the one that's in 142 countries. It's a very easy process through the Canada Patent Office to get your patent extended into these other 142 countries. The unfortunate thing about patents is it doesn't necessarily protect against re-engineering or reverse engineering. So if they see the issue that you're solving, but they find a slightly different way of solving it based on your designs, but it's different enough that they can call it a different product, you're not protected against that. And unfortunately, there is no real protection against that. That is a risk that you have to take on. But sometimes the reward is worth more than the risk. So here's a couple of kind of agreements that you can enter into with a contract manufacturer to help protect yourself. Non-disclosure agreements, so that's basically saying that they won't go ahead and tell everyone about what it is they're making for you. Non-compete is that they won't go to your main competition in the field and make this product for them. And both of those usually have an expiration date on them. They're for a set amount of time. And it's very important to note, we as a prototyping company do provide our NDAs to our clients when we meet with them, but a lot of companies don't. It's not their obligation to, it's your obligation coming to them to bring your NDA or your non-compete with you. So it's important to keep in mind that this protection is there for you, but you have to seek it out. You shouldn't expect somebody to hand it to you.
And finally, we arrive at the risks. So obviously, our talk has been very much focused on all the things that can kind of go wrong in terms of mass manufacturing or contract manufacturing. Like I said, it's kind of a necessary evil. You absolutely need it to sell high volumes of parts, but there are going to be some things to watch out for along the way. So we're going to kind of go through those a little bit more here. So the first one, as before, is quality. Again, this is your baby. Now you're not the one making it. How can you be sure that this is going to turn out the way you want it to turn out? Because once you're in the manufacturing stage, there's less room for error. It's not like you can print another one. It's not like you can make another one in your garage. It's you're getting a massive box of these things or shipping crates or an entire transport truck, and that's how they're turned out. That's it. That's what you paid for. That's what you sent. And higher volume obviously leads to more potential in terms of quality control. So the more someone makes of a certain part, the more likely there is to be a few bad apples in the bunch. And that's kind of unavoidable. Machines will sometimes go wrong. Sometimes, a material will stick where it's not supposed to stick. So you will always have certain bits that just kind of escape quality control and make it through. I imagine most of you here have bought a product. IKEA is generally pretty bad for it. Where you're either missing parts that are supposed to be there, or one of them doesn't work the way it's supposed to, and you kind of have to go back. That's because they make so many of these things that it's almost impossible to guarantee 100% quality control. So getting as close to possible in your design, doing maybe after quality control after it gets back to you from the manufacturer, are all ways of trying to reduce that, to make sure that what you're giving people is something you are proud of. The next one is reliability, and this is one people don't think about a lot. So will shipments and supply be consistent? So if, for example, you order a fairly small order of like 1,000 of your products. And because you already have 1,000 customers waiting, maybe they're early adopters, maybe you ran a Kickstarter and that's how many people have ordered them. So you get your run of 1,000, you sell those, you're starting to get more popular, you're getting a whole bunch of orders in. Can you be sure that your manufacturer is going to get you those parts on time in order for you to keep that flow going? Or are you going to have to communicate to those customers being like, I'm sorry, we don't have any right now? A good example is, and I don't know how many people tried to buy them, but when the Raspberry Pi first came out, they were nearly out of stock for an entire year. It was almost impossible to buy anything released Raspberry Pi related for a year because they simply could not keep up. And Kickstarter, crowdfunding has been a huge thing in the last little while. I don't know how many of you guys are considering it, but a lot of the Kickstarter companies have a big issue with this, is they get a lot more attention than they were expecting, and now they spontaneously have to deal with a volume that wasn't even fathomable when they first started. So making sure that you can deal with that in as best as possible is generally something to consider. Because it's a good problem to have of you're more popular than you thought you would be, but still. Well, the quality of parts be consistent and stay within the given tolerances. So again, if you get one shipment of, your first shipment of 1,000 and they're all fantastic, generally it's a good sign that the rest will follow, but maybe they're just trying to impress you on the one-off and you kind of have to still keep your eye on everything else that comes. Perhaps they change factories, perhaps they start outsourcing what you outsource to them. You always got to keep an eye on what's going on. And then finally, is the relationship between you and your contact dependable? So generally at these kind of things, you're talking to a single person. You're like, I need this many by this time, or I need this many on a regular shipment schedule. Is that someone who you can depend on? If you get that communication message across to them, is it hands off from then on? Can you just be like, okay, good, they're taking care of it, perfect, I don't have to worry anymore? Or is this someone who might just spontaneously not get your email address, not get your email message, and then you don't get your parts for all the clients waiting? So building up that relationship, like I mentioned earlier in terms of communication, it can be extremely important for making sure that your customers, and therefore you, are kept happy. And then scalability. So again, this kind of goes along in hand with the Kickstarter thing in companies. If you start growing a lot faster than you expect, can your manufacturer keep up? So not only can you keep up and get those shipments in time, but do they have a big enough factory to produce enough parts? So a good example actually is us here at the Fortin Discovery Lab. So we are a generally small product, small volume shop. We'll do design all the way to small volume, but if someone comes to us and says, we want 1 million of something, that's out of our hands. We cannot do that. We can probably do a couple hundred, we can probably do 1,000, but if someone comes and asks for 1 million, we're the wrong place. You want someone with a much bigger factory. So making sure that you are with a manufacturer that can either scale up with you or is simply large enough at the start to keep up is very, very crucial to keeping your company's growth and predicting exactly what's going to happen as you grow. Will scaling up the volume affect the cost and quality? So for example, if you do step up in more parts, are they going to suddenly change the cost on you? Generally not a problem, but something to try and keep in mind. And will the quality change? So if you go from ordering 1,000 ordering 1,000 parts per shipment to ordering 10,000 parts per shipment, are they going to rush them and in turn have worse quality? So trying to account for that is also, again, important to keeping your customers happy. And can your manufacturer support additional products or product lines? So say your first product is doing really well, your manufacturer is doing an amazing job, you're really enjoying what you're doing, and you come out with a new product related to your first one or still under that same company umbrella. Can you use the same manufacturer, or are they going to say, no, you've got to go find someone else and go through the entire process? Because now you're at the problem of your first product is doing really well, and people are happy with it. Now you have to try and match that with an entirely other different company. So again, not usually something to worry about, because if you're at that point, then probably a good problem to have, but still something you might want to consider as you go, depending what you're expecting to do with any of your given companies. And then there's interpretation. So generally in your design, there should be no room to very little room for interpretation. You should be able to send something to someone and they know exactly what it is. So they get the engineering drawings, maybe they get the 3D model. There is no room for error. But depending what you're doing, so clothing is a little bit harder, anything with kind of a more free-form style material is a little bit harder. Can you guarantee that what you send them will be interpreted correctly on the building end? So if you send them a drawing, are they going to look at this and be like, oh, maybe it's this way, and then what you get actually has a cut where there's supposed to be an extrusion or something like that. Usually you can try and solve for that as much as possible in the design aspect, but it's still something to try and consider. So before you send something off to a contract manufacturer, maybe it might be a good idea to hand your design around to other people in your company, other people you trust, or other people within your umbrella of safety, and see and make sure that they interpret the same thing you do. Are all details clear and communicated properly? That goes in the same hand. Like if you say, I want this blue, do they know exactly what shade of blue? Small details like that can go a really, really long way when it suddenly arrives in your hands and it's not what you thought. And are you confident that they understand the product? So do they know what it does? Do they know what it's used for? That will generally help in interpretation. So if you send someone a design for a sock, you don't want them thinking it's a mitt. Generic example, but still. And trying to deal with that. So finally, contract manufacturing can be really difficult to start. It's a nightmare, it's terrifying, it's a necessary evil, but once you get it going, it can be pretty easy to keep going. So once you get that first shipment and it's good, and once you get that second shipment and it's good and it's on time, a lot of the times, that's it. They'll keep working for you, you'll keep paying off, you'll keep getting the products you want, your customers will be happy, and you can just go on from there without having to worry about it anymore. So it's going to be one of those last big, terrifying steps that leads to the success of your company. So necessary difficulty, and be careful not to rush any of these decisions. Say you're really trying to get these made fast. That doesn't mean Google search contract manufacturing, find the first person you see, and then get them to do it. It means actually do good research on the people who are going to be making your stuff. Again, this is your dream, this is your idea, this is your baby, you've built it from the ground up. Make sure that when it gets to that final step, you don't cheap out, you don't rush. You still want everyone you're involved with to be happy with what you're doing, and more importantly, you want to be proud of what you're giving people, because that's going to be your legacy. That's going to be what gets you higher, and that's going to be what keeps you going. So besides that, feel free to ask us any questions. There's generic contact information there. We'll probably move to the shop for questions, because we can actually give you examples of what we're talking about. So when we're saying molds and dies and parts that cost 10 cents per run, we can actually show you what those are, and including some of the things that might go wrong unforeseen. So hopefully some of those examples will make a little bit more of what we said clearer. And yeah, feel free to follow us to the shop. So if there are any questions, feel free to kind of interrupt me at any point, and we'll answer the best we can. Other than that, we'll kind of just do a quick run. So when we say additive versus subtractive, additive manufacturing is kind of what's over here. You can see the 3D printer going off in the distance. If anyone's curious, yes, you're welcome to go look through the window. That's why it has one. All right, thanks. And then when we say subtractive manufacturing, you kind of move towards the back of the shop. So we'll also show you the CNC there and what we mean by we take big pieces of aluminum and mill them down into something that's actually useful.
An example of that is actually this piece here. So it grooves out the inside as opposed to adding the aluminum up. It takes the aluminum off.
Right. So when we were talking about molds and dies, that's exactly what this is. So these two pieces here are generally fairly expensive to make because they require a high degree of angle, so you guys can talk about it. You can take out the parts from this in a matter of a couple minutes and for under $1. And those, the aluminum generally 10,000, I think? 10, 20,000 parts in aluminum stuff?
Yeah, you're looking in the 10 to 100,000, depending on.
Yes. So, you know, one of those molds might cost you 5,000 to 6,000 for a small part, but then parts from there cost 10 cents. So if you remember those grade 6 optimization problems of trying to make the lines meet and figure out that precise point, it's exactly what this is. So it turns out the math you do learn at grade 6 can be helpful. Yeah,
After grade 6, though.
That's the end of it.
Yeah, after grade 6, it's all yours. So again, I'm going to run through this. So this is an example of for a company in Florida. I know it's very tiny, so I'm going to run around too. But it's a casing for a pocket thermal camera. And they only wanted about 100 of these in total just to kind of show off their technology. So there was no point in getting that whole several $1,000 complex mold made. So they just got us a 3D printer. But if a company was going to make hundreds of thousands of these, printing them would take forever. For example, making 10 is a 60-hour job 24/7 on that thing. So we're trying to fill an order of 90 right now, and if we run that thing 24/7, it's not done till March 8th. So not exactly the fastest in terms of delivery. So one of the things we're going to kind of pass around now is an example of what should come out versus what might come out, even though it's from the same thing. So I'll pass them around so you can see them clearly. But one of these is how the part is actually supposed to look and function, and the other one is just a part gone wrong. So if you order, several thousand, you might wind up with a couple of these that are completely useless.
That's a
and
pretty
it's something to keep
drastic
in mind.
example.
Yeah, this is a drastic example. Usually it's more like it's slightly bent or there's one part that didn't quite fill in. But drastic tends to be a pretty good way of looking at it. So this is one of the things we mentioned when we said certification. So for example, you're looking to sell your product. Is one of the things you considered weather. If you're making it out of plastic, is that plastic going to be brittle in winter? Because I remember one point we had a little outdoor garbage can. The second it got cold and I accidentally kicked it, it just shattered. So is that one of the things you've considered? And if not, is it one of the things you have to consider? And that's what this machine's capable of. So this will go from negative 60, positive 180? Yeah. Negative 60 degrees to positive 180 degrees and 10 to 90% humidity, and see whether it works in that entire range. So if you do want it to work in a Canadian winter, you can make sure it will. If you do want it to work in a jungle, you can make sure it will. More importantly, in Sudbury, if you want it to work in a mine. Personally, doesn't matter to me, but we can check.
You'll need tags like CSA approved, FCC approved in the States. There's a different set for European countries. Basically what you do, you stick your electronics in this chamber, and you can tell whatever frequencies are coming off your product, and you can bombard your product with the frequencies to tell when it's going to either get interfered with or interfere with something else. And there's a set of ranges that you can't go past, and that's how you get your certification. This certification can cost about $15,000. We can do it here, essentially free. So that's a pretty big advantage. There are 2 of these chambers in Northern Ontario. Tom Fortin owns both of them. So,
Hospitals will tell you, please turn off your cell phone. That's because if there are any delicate machinery, which in a hospital there are many that people's lives are dependent on, they don't want false readings. The last thing you want is a machine telling you you're dead when you're not. Other examples are, again, in mines. In mines you have to not touch certain frequencies because that might set off an alarm of something's broken, something's gone wrong, and you have to make sure that it's... Yes.
Explosion.
Also, please turn off your radio during blasting zones. Same thing. The last thing you want is some blaster putting explosives in a hole only to suddenly explode. It doesn't happen really, but it's always theoretically possible, and therefore people try and prevent it. Those certifications are meant to make sure that you never touch the ranges that are used for things like that. Common examples are also FM radio, Wi-Fi, cell phone signals. Those are all ranges you're not allowed to use because they're dedicated to something that people depend on.
So those molds that you saw earlier, they were made here in-house in this machine. There's another individual whose expertise is controlling these. But basically you start with an aluminum block and plan that you create through software, and you end up with a mold that you can make, your run of 500,000, 10,000. It's all tooled up and specifically for aluminum gear, but those molds could be made out of something more durable in a higher run production facility.
So, as I said, those molds are made at really, really high pressures and really high temperatures. So you want to use materials that will work less under those conditions. Aluminum is pretty good, but it'll melt at 660 degrees C as opposed to a steel at like 800 or 900. So it's a little bit less durable, but for us, it's a lot softer, so it costs a lot less for tooling, et cetera, et cetera. It's a pretty good compromise. We have 2 more CNCs in that room. They're designed specifically for plastic, so we sometimes do detail work on our 3D prints using that. Especially for smaller holes, 3D prints will sometimes kind of lose accuracy in that area, so we'll just drill it out. It's a lot faster that way. When we 3D printed Groot, his arms over here, we need to print on top of something else. So it needs to print a material all the way up here, and then print his arm on top of that. But we don't want that part there afterwards. So it prints it in a different type of material that when we put it in that chemical bath, it gets rid of it. It's a support material. So you can actually see it here. It's a little bit more brittle than the model material, but it comes off easier. That's the point of it. So it actually takes an extra 8 hours to 12 hours to get that support material off after you've printed the part. And as we've mentioned, 3D prints can take a long time. So they're not quite as instantaneous as some people would think.
black one that's not currently doing anything is one of those $3,000 to $4,000 machines that people advertise as like home manufacturing. They're great fun. Anything that's around the MakerBot is from that machine. Anything that's on these pedestals here, except for the Velociraptor, is from the big one. So feel free to come over and take a look and pick them up and see what the quality's like. And it's kind of just an example of what we were saying in terms of the manufacturing dynamic is slightly shifting. People are learning how to do this on their own. People are learning how to do this in smaller volumes at smaller places, and without that need to go to a giant Chinese company and do it that way. So it is going to be really interesting to see how both parts play out in this, in terms of will they do something else to advance themselves, or will the gap actually fully close? And the little MakerBot's a great example of that. Hi.
And to give you an idea, 3D printing is a sector that's predicted to grow by a factor of 2 for the next 10 years. So in 10 years from now, 3D printers are estimated to be 1,000 times better, which is a pretty significant jump in a fairly short amount of time. So it's not unreasonable to think that in not that long from now, people will own a 3D printer a lot like they own a laser printer or an inkjet printer. So that manufacturing gap is shrinking, and it's doing so a lot faster than we think. It is difficult to compete in terms of labor costs, and because of the sheer volume that they have. Like our shop, we have 2 injection molding machines, and I mean these things shoot plastic in there at hundreds of degrees and several tons of pressure. So these machines are expensive, and you need a lot of them to pump out parts. So it really is hard to compete with that, but we have access, because we're NORCAT, to FedNor, Nickel Basin, Trillium. There's 7 different funding companies that work with NORCAT, and we have access to all of that. So we can definitely try and offset that price. The government is willing to help you if you decide to go with a domestic route as opposed to a foreign one, because they realize the advantages of keeping it in-house. We can try and offset it a little bit too. And we do our best to compete, and especially time-wise, we like to think that we can compete in terms of getting the product in the same amount of time. But for the final cost, I mean, it kind of depends on what you're looking at, the size of the run, but we will do the best we can to at least get close to that margin.
It's also important to note that that's always been the horror story that everyone has had, right? That it's so much cheaper, just go to China and get it done there. That gap's actually closing because of stuff like rapid manufacturing with 3D prints, or the small injection molders that we have in there. And yes, $50,000 is a big investment, but if you can do it so much faster, and you're now dropping that, so it's not a 90% gap anymore. It's probably closer to a 40% gap, which is still a lot. We're talking about your bottom line, but domestic production is catching up to the point where China is at.